We are now moving into the second half of the sessions, which is the panels. Let me just introduce the leader and the moderator of the panel, and he'll, I'm sure, get a nice and interesting conversation going. So please welcome from Accenture, Jefferson Wang, Chief Strategy Officer, Cloud First. Please give him a big hand. Sorry.
I'll just save time and just introduce and invite the entire panel up while we're here. Everybody's here. Yeah. We'll figure it out. Yeah. Great. Well, first, everybody, thank you so much for spending time with us, and welcome to the new norm for data centers. I think one of the most interesting topics we'll talk about today, and first just want to thank ION Global Forum for having us and bringing this topic to life. You know, we were kind of reflecting a little bit on this, and you know, I grew up in the network space, and now that you look at data centers, if you look at it, it was 5 to 10 years ago, people would have said, hey, that's not maybe a career that I would want to get into. Our data center is going to move into the cloud, and it's not necessarily a career we want to get into. But now, when we were walking here, Maruta-san and I were talking that the goal is to get to 1 megawatt per rack. And you think about how crazy that is when you really look at this. So why don't we do this? We're going to have just a chance for each of the actual panelists to introduce themselves, tell you a little bit about their company. Myself, Jefferson Wang, I'm with a company called Accenture. I'm our Chief Strategy Officer for our Cloud First organization. And then maybe Derek, if you don't mind, kick us off.
So Derek Buckley, so I'm Managing Director for Telecoms, Media and Gaming for Microsoft.
Great, and Lieven, please.
My name is Lieven. I'm a strategist in product strategy, obviously, for Nokia, Senior Director, and I love optics.
Who doesn't love optics?
Okay, I also love optics. I work for NTT. I'm leading NTT's R&D efforts for ION, and at ION Global Forum, I'm serving as the technology working group chair. So my name is Masa Kawashima. Of course, I love optics.
And I'm Toru Maruta with KDDI. I'm an executive officer in charge of technology planning and strategy, currently working on AI data centers.
Okay.
Hi, Murinder Singh Sambi. I'm part of Google Cloud, Vice President for the cloud networking portfolio.
Great. So I think you could see an incredibly diverse panel, and I think it was really important to kind of make sure that we had a blend of telecom operators, a blend of hyperscalers, and a blend of the actual industry. But if you just kind of step back and just look at the background of this, where you literally can't trip without talking about AI no matter where you go, but then you naturally reflect on what's AI going to do to data centers, right? I mean, and what type of pressure is it going to put on power, space, cooling, and real estate? So maybe, I guess the first kind of key thing we would ask is, Maruta-san, you've been in data centers for a very, very long time. Mm-hmm. And when you look at this, what do you see as kind of some of the impacts of this new AI wave onto these data centers?
Well, the impact is huge, and I want to start from what we currently had or what we were using as a data center. KDDI is a mobile network operator, but we originally started from telephony. And in those telephony network center, it was the name. Now we're calling it data centers. But those were like a 2 kilowatt per rack data center. And what we see now for AI is we're looking into 150 kilowatt per rack. That is what is required for the newest GPU. And so the difference is like 100 times. So the impact is huge, and we are trying to reuse the telephony data centers into the AI era, but that doesn't work. So we are getting new data center which is able to supply water cooling and also the power for this AI infrastructure. So the impact is huge, and what we're doing is we're trying to get that infrastructure as soon as possible. And so that's the impact we're seeing. And how we're going to do it as soon as possible is like repurposing factories or using containers as a data center. So we're using those techniques to get it faster, but that's the challenge we are seeing.
Yeah, so I mean, I think an incredible amount of innovation needs to happen at the cooling level. We have to kind of figure out how to plan for this differently. But there is technology innovation happening, and maybe that's, Maninder, something we can ask you about. When you look at kind of optical as a technology, we obviously have big fans of optical on the panel here. So when you look at the value of direct connecting optical to a data center, can you share a little bit about what's happening in that space and what you see the value is?
Yes, absolutely. So AI, there's two types of AI applications that are being developed. So we have to segment the workload type because they have different characteristics of what the network needs, and that sets very well into what the optic strategy needs to be. Obviously, AI training, very bandwidth intensive, a lot of data transfer. You can think petabytes, zettabytes, if not more. You want to be able to have that being able to do over a very dedicated, lossless, equivalent to lossless, so that you can transfer mega petabytes from one data center, from a cloud, or from a warehouse or an AI infrastructure that is on-prem into the cloud. Now, with that, I think the world was really good prior to this AI training workload going up to 100 gigs per second. So we had interconnect that could actually offer to connect to any other cloud or even to on-prem infrastructure with 100 Gbps. But now the speeds with this big data transfer for customers who are trying to become model creators or model optimizers, they're sending in petabytes and zettabytes for which you actually need something that is way above, which comes to about 400 gig in the future, 800, and will evolve to 1.2 Gbps. But it's not just about the speed. It's also about how we will connect. Because as you introduce faster speeds, yes, you get lower latency, but with the additional hops that we introduce from a networking infrastructure, every hop introduced, it acts on latency. And that's where I think the optical technology has to keep up, where we don't have to introduce networking equipment, we have to eliminate networking equipment, but still be able to provide high bandwidth, high performance with no compromise to what latency would have been.
I think we used to talk a lot about latency, but I think also just characterizing the business value of that too is like what type of performance improvements or degradation do you see, and ultimately what type of value you can get out of it is also important. But I think that clearly when you architect this differently, that can be an issue, but how do we characterize that on the business front is super important. So I really like that you're bringing that up on the value side of things. So when we look at ION technology specifically, all photonics networks has been incredibly important, and there's real depth of innovation happening. So maybe Kawashiba-san, can you first maybe baseline us and really just talk about what an APN is as a starting point?
Okay, so APN stands for All Photonics Network. It's a new DWDM-based optical transport. Of course, everybody knows DWDM. It's a network for high-capacity data transport. But ION APN is a new type of DWDM transport with two features. One feature is dense area coverage. Today's DWDM transport systems are operated with large ROADM systems, which can be deployed to carrier's backbone and the cloud service provider side. So basically, the deployment points are limited to large sites. But today, we see many use cases where we would like to deploy DWDM endpoints to much smaller sites, such as radio towers and small data centers and so on. So this is where APN comes in. APN will achieve dense area coverage by disaggregation of transport system. I think many of you know the 5G RAN architecture. 5G RAN achieves high antenna density by disaggregating radio base stations into 3 tiers, CU, DU, RU. Similarly, OpenAPN achieves high dense area coverage by disaggregating ROADM systems into 3 tiers, exchange node, gate multiplex nodes, and transceiver nodes. So with this, APN will achieve high dense area coverage. This is the first feature. And the second feature is dynamic control of optical transport. Of course, we need to make all the IT and network resources software defined to be operated as a part of cloud computing infrastructure. Packet networks can be treated as software-defined resources. But today, optical transport cannot be treated as software-defined resources. But ION APN will make optical transport be treated as software-defined resources because APN nodes can be dynamically reconfigured from the controller. So we can dynamically set up and tear down optical connections like we make phone calls. So this is the second feature. And as to the benefits to data centers, with ION APN, we can keep building data centers without facing pushbacks from local communities. Today, data centers are getting bigger and bigger, and they are concentrated in small geographical areas. So many local communities are now fighting against the construction of new data centers. So with ION APN, instead of building a small number of hyperscale data centers, we can build many small or medium-sized data centers and interconnect them to form one logical computing space. So with this new paradigm, we can keep building data centers without facing pushbacks from local communities. That's the benefit of ION APN.
But I mean, just kind of think about that statement, right? Where 10 years ago, that's not possible. You have to find the real estate closest to where you need this to be on compute workloads or people. And now, because there is a new network innovation at the photonic layer, at the optical layer, you can now completely re-architect this, where you don't need that prime real estate inside of a city, which has a ton of cost on top of that. And now you can re-architect this so that you can actually have the data center sitting somewhere else. But this low latency, high performance network allows you to do that. I mean, that wasn't possible before.
Not possible before.
Right. And we'll get into some of the business values beyond that, but that is a very big statement.
So of course, one of the business benefit is we can keep building data centers, and we can take advantage of the rural areas as a place of data centers. So with this, basically, for example, real estate developers can develop new data centers taking advantage of rural areas. So, and this is good. And also, for urban areas, probably we would not have to build new data centers. Instead, we can connect urban areas, buildings, with suburban data centers over APN. So we can reduce the number of data centers in urban areas. So this will help us, this will help societies achieve decarbonization of urban cities.
Yeah, that's a great point. Levin, you've always, Nokia has always been extremely strong at the optical, among other things, right? But when you look at kind of data centers, what other tech aspects should we be thinking about when you look at a data center?
So I'm going to look at Nokia, but in the scope of ION Global Forum. So we are, of course, we have our data center switching fabric, but I think the most important thing is what we've talked about throughout is actually the energy efficiency, and to see how we can actually do the optimization from a carbon footprint point of view. So we are working within the ION. It's currently called Energy Efficiency and Sustainability Study Item. It might change to Economic Energy Efficiency, because to the point from Kawashima-san, there is also an economic part, and the economic part is not only on the compute and the power consumption locally, but where you get the power from. So we need to have tools in place that can do that. So data center interconnect and inter data center connections are very important. And of course, we have products for that, and they are on the optical layer, so I think that's the best way forward. I'll give it back to you. I'm forgetting something, but I'll get back to you.
Yeah, no, it's good. And then, I mean, I think we focused a lot on kind of the value and technology side of things. One thing we haven't gotten to, Derek, is the business transformation, the business model changes, because I think that's another really key point. You know, from a Microsoft standpoint, how are you looking at this from a business transformation, new business model, that side of things?
Yeah, no, I think it's a great question. And I think if you look at it from both the consumer and enterprise perspective, it really kind of, this ION technology really kind of enables them to adopt very strong solutions like the AI embedded in their business processes and really build a more efficient business moving forward. I think in terms of, if you just look at, to Kawashima-san's point, this is going to encourage mass kind of CapEx spend on building these data centers. It creates a bit of diversification that no longer do data centers have to be in metropolitan areas. We can then start building them in rural areas and stimulate the economy in a rural area as well. So it's a very different dynamic and economic proposition to what we previously had.
Yeah. And that rural area isn't just necessarily tech skills that's generated. There's the utilities, there is the real estate community. There's so many other things that are pushed off of that.
Absolutely. It's the entire supply chain.
Yeah.
Okay. So it's quite expansive.
So when we look at, maybe now we kind of think about it from a use case perspective and what's tangible. So Maruta-san, when you look at the use cases with this new AI implication of data centers, what use cases can we expect? What are you excited about?
Well, first of all, we started building AI data center, AI infrastructure, and that we have a high performance GPU inside that is fit for training of foundation models. And actually, we don't do the training for foundation models, but we do fine tuning. So it's like there's foundation model builders, and there are people who are doing fine tuning for those models, and also there's going to be inferencing. So we build a model, but how to monetize it? We need to use it to make money. And inferencing stands for that part. So eventually, whatever model you build, you want to use it to serve customers, and that's going to be inferencing. So our goal is to serve inferencing, and so that's where we believe the network can serve as a touch point for the end customers, and there we provide the inferencing AI and to do the business. But to do that, we need the foundation model. So there's people who are building the foundation model, and people fine-tuning it to fit their needs, to fit their business needs, and then at the end, there's going to be people who are serving that and collecting money from the end users. So that's the business model I see, and the impact for data center is when we serve the customers, we need edge data centers, and so we want to be at the edge to serve the customers. But that's not always possible. That's one thing. And also, the latency perspective, we don't really need to be at the edge. Even if we are at the far end, if there is a fast communication link, like what APN can provide, that'll be able to serve the end customers. So what I'm saying is, we want to serve the customers at the edge, but at the same time, there's some constraints that are so that we cannot serve the customers at the edge, and we have the technology to serve customers from the back end, but have the same kind of quality to serve them.
Yes, I think this is a good point. ION APN will change the structure of edge computing. Before ION APN, we used to think that computing should be deployed near customers' places to solve the latency issue because ION APN provides high bandwidth, low latency connections. Probably we don't have to distribute computing resources. Instead, we can connect customers' sites with centralized data centers with ION APN, and we don't have to be worried about latency. And we don't want to deploy computers in urban places because urban places are facing energy consumption issues.
Yeah, this allows you to actually think about use cases in categories and define the edge differently, right? So now, if there are use cases that are more real-time focused that you need to actually make a decision on very quickly, if it's a manufacturing line and you need to decide on something for worker safety, on the quality of a fast-moving line, that is a very time-intensive decision. And before, you only had one way to architect it. It was an on-prem, situation. But now you have optionality when you look at it. And that takes cost out of the system, but maintaining kind of the output. So that's pretty interesting. We're going to give a chance to have the audience ask questions. So start to think about that. And feel free if you just kind of raise your hand, I'll get to you, and then we'll kind of, dole it out. But, so start thinking about your questions. Probably after this one, we'll give everybody a chance, then we'll keep rolling. Muninder, when we talk about technology innovation, business model innovation, one thing we didn't get to is kind of ecosystems, partnerships, and those pieces. So when you think about the actual partnership innovation, the adoption of kind of multi-cloud, you've got Microsoft and GCP on stage, which I think is a big deal, by the way. And when you look at that, what do you see with customers adopting multi-cloud? What are some of the benefits? Because Google also has a very focus on your own infrastructure. I mean, it's a pretty big deal.
So first of all, I think 70%, as per analysts, 70% of the enterprises will have a multi-cloud strategy.
Mm-hmm. Say it one more time. 70% of the enterprise will have a multi-cloud strategy.
Will have a multi-cloud strategy. In fact, with Gen AI and the ability to consume GPU, TPU infrastructure, and the somewhat capacity restriction is driving that number to be even higher. And that's predominantly driven by the fact that you want to have the GPU, TPU infrastructure that you need, both for training, where the model creators and the model optimizers are going to run high performance, predictable latency. I want to be able to get my data. I want to be able to create checkpoints and run models to training my data. And then inferencing, as you talked about, is very much allowed low latency. Inferencing, just imagine you're doing you're talking to a model, and it takes 5 seconds for the prompt to come back. By the time you've lost the attention of that particular user trying to do research or even analysis.
You would bail on the situation.
You bail on the situation, you'll walk away and say, I want to use some other system. So it's very, very important and data is everywhere, right? Data is in the context of on-prem. It could be in a cloud provider. It could be in Google. It could be in Microsoft. It could be in any other cloud provider. And data has to move in order for the models to be created and optimized for. So you want to be able to, the whole notion of just like the example that he shared on inferencing at the edge, your edge compute cannot have that GPU, TPU capacity. You want to have a very simple, fast, low latency in connectivity back into the cloud. Having to go through a co-location or a carrier-neutral facility and being able to stitch multi-cloud and trying to send traffic back and forth, again, you're introducing multiple hops. You want to have exactly how you want it to connect on-prem asset into the cloud. You want to have connectivity between the clouds at the same point. So at least with partnership with AWS, Azure, and everyone, we have cross-cloud interconnect that Google offers, where you can actually patch in your customer VPC in AWS and patch in the Google VPC without having to have any physical infrastructure that needs or adds latency to it. Now, second, I think is, when it comes to inferencing, it's going to be very interesting because inferencing is all about low latency and GPU efficiency and making sure that we do security along the way. And low latency is, I think, where technologies like ION can actually provide enhanced value, because you might actually run out of GPU capacity in a particular cloud, and you want to burst into some other cloud or in some other region within the same cloud. And you want to be able to provide that seamless experience. Now, as we know, regions are going to be separate in geographically dispersed as well. And you run into the science of the laws of physics, where some milliseconds will be added. But if you have a neighboring cloud provider in the same region, you can now burst to that GPU TPU capacity for inferencing, assuming that interconnectivity between the cloud providers, between the on-prem infrastructure, is now supported by a low latency, predictable latency, almost like lossless Ethernet equivalent technology.
When you kind of hear what the speakers are bringing up, what kind of questions does the audience have, and are there any things you want to go deeper on? We have mics, so Barbara has mics in the back, and then we've got one up here.
Hi, thank you very much. This is Adnan with Enritsu. I'm new to ION, so it may be a dumb question, so pardon me for that. The first thing I'm trying to understand is if we're looking at having edge compute away from the user, so the term edge compute may, become irrelevant down the road, right? Mm-hmm. Yeah. And second point I had was, are there any regulatory or interoperability standards that define how these data centers can be connected? Because you could have some sort of a neutral host, for instance, whereby workloads can be running by different vendors for different applications. So do these standards exist from a regulatory perspective and interoperability perspective? Thank you.
Maybe Kawashima-san, you'd like to take the first one, and I can try to take a stab at the second one.
So maybe I can answer the standard thing. So basically,
we're going to flip it. Kawashima-san's done the second one out of the first one.
What was the first one?
The first one is the definition of the edge changing. But that's the easy one. I'm going to take that. You do.
Okay, of course. I call this edge computing 2.0 because
now he's taking the
edge computing because we don't have to we don't have to have data centers distributed near customer's site just for the purpose of reducing latency.
Yep.
Instead, probably we would need small data centers near users' working place just to help users' business activities. For example, users want to develop AI products, developing, customizing AI models. For that purpose, customers need a place where they maintain their precious data, because data is their asset in AI-driven world. So data centers near customer sites would be used as a place of data, while data centers in rural areas would be used as a place for AI computing. Mm-hmm. So in future, the separation of data and computing resource would be very important. In this world, we don't need edge computing, but we need edge data centers as the place of data maintenance.
Does anybody else want to add to that? Yeah.
Go ahead.
And then leave it. Yeah, go ahead.
Well, I think when we talk about edge compute, it was about latency. Mm-hmm. And think about what we're talking about. We talk about Gen AI, and we say the response should be in seconds, 2 seconds maybe as an average, and if it's more than 5 seconds, the user will walk away. And the latency we're talking about for edge data centers, that's like milliseconds or tens of milliseconds. So the order of magnitude is totally different. So as AI catches up and the latency becomes smaller, then I think we need to care more about what the latency of the network is. But at this point, when we're talking about AI, the network latency is not a big thing. Yeah. And in that context, we can live with the far-end data center to serve AI.
Yeah. And Levin, did you want to add?
I'm not sure, but are we going to go to second question? Because you talked about neutral host, and I think one thing that we've talked about is actually how data centers interconnect. Mm-hmm. talked about it. We've talked about we can put loads. What we haven't talked about is how are we going to get access to it, because the density, or the how do you call it? Not every site is fibered up. Not every site that is fibered up is accessible through directly via an APN through an operator's network. So I think we should envision that there is going to be a neutral host. I want to have my load on. I don't even care where the network is going to bring, or the load is going to be done, but I need to have connectivity. That connectivity needs to be inter-APN, because you will have an operator neutral host one, and then you will have a big cloud provider as well. So that means you need to think about the data plane. We have a work group working on that. But you also need to think about the control plane on that, because your VIA portal, the enterprise will say, well, I have a load, my data sits there, to the point for Kawashima-san, and the compute, well, I'll decide, and it's not going to be the end user, it's going to be the one that owns the GPU, saying, well, it's better there. But then you need to provide that connectivity. You need to have that agility to go there. And when you don't need it anymore, you let it go. So those are the aspects that we need to take into account as well.
Yeah, I think it's a great question, and thank you for being new to ION. That's awesome. I think the definition of edge changes, and what we want to do is be able to allow technology to create the optionality. And that's the really important point here, right? That the definition of edge can be right next to the user, on-prem, near, or far. But the real key is that ION is allowed, or is enabling the optionality, because each of those has a decision point, right? So basically, you could take cost out of the system if you don't have it on-prem, right? On-prem is a ton of control, but there's a cost associated to it. So now, does this technology allow you to kind of take the cost out, but your performance is still there? So I think that's the really cool part about your question, because you're right, it was a very defined statement. It was like, well, edge is on-prem, right? And there's certain industries that require that, right? There's certain industries that want an air-gap solution on-prem, and that's perfectly acceptable. But there's other industries that have trapped data sitting on-prem, and it's too hard to extract it out. So can we bring the AI to the actual data itself is another optionality. So I think it's a really fun question. Yes?
Hi, my name is Kevin Short. I'm a research project leader in optical communications at Airbus. And Moninda, you mentioned this 5-second irritance that latency has. If people have to wait 5 seconds, then they're going to walk away. And I feel like latency is always this omnipresent subject in optical networks. And but one thing that I've always wondered is, what kind of price do folks on the panel here put on a millisecond saved, 2 seconds saved for various applications? Is it a matter of, from an enterprise level, for example, we talk about data center interconnects. Is that something that a data center operator will pay $10 million for to save 2 milliseconds? Is there any kind of sort of order of magnitude that everybody works with?
Do you really want a dollar value? Because that might be a bit of a challenge. But to try to answer your question in a more high-level point of view, it depends which industry. If the industry has money, they will probably more be likely to deploy it. And think about it who has money? Well, the financial industries. So if you think about that, they actually rectified a fiber optic line to make sure that the trading centers could shave off not even a second, difficult, but milliseconds and all that. That was done. So I think that where the money is and there is a need for it, they will actually go for it. Now, to put numbers on it, it becomes how far is it, how much your capacity. So that's a little bit more complex. But I think, yes, it will happen. The question is for which industry and maybe what can you do. If you need to pull a new type of fiber, think about hollow core fiber because you can go so much faster. Sure, but then you're back to your question. Sorry.
One data point I can also share. I mean, it's very hard. This is a new world. I wish there was a very simple answer. X millisecond cost.
I didn't want to ask a simple question.
But the way you can look at it is any network latency for any prompt that you've sent to GPU, TPU, AI infrastructure you're holding time on the GPU TPU infrastructure. Network cost is significantly lower than the cost that the enterprise is going to pay for holding that token in that particular GPU for processing a particular job. To eliminate any latency the network is going to add, because it adds up to a tremendous amount of cost on the GPU infrastructure, it's easier to justify the ROI to have a low latency, high performance link at that point.
I think I want to make one comment. So this is not a pure technical question, but it's more about business model question.
Yes.
And one unique feature of ION Global Forum is that we have many members from various industries like financial service institutes and banking and so on. And when we often discuss the latency saving how the latency saving can be monetized in the financial service institutes. For example, financial service institutes want to deploy high-performance database systems with synchronous data replication. So they want to deploy 2 database systems to 2 data centers, and they need to find a pair of data centers with today's technology within 30 kilometers distance. But if we could make a pair of distance located far apart, like 50 kilometers and so on, then they can take advantage of data centers with lower floor price. And that would be their economic gain. So we do this kind of study, how to translate the latency saving into economic gain at ION Global Forum. I believe that for innovation, one of the important study is techno-economic analysis, how such technology performance improvement can be translated into economic gain. So we are doing such studies at ION Global Forum.
Yeah, I think it's, yeah, go ahead, Marissa.
Yeah, one thing as a network provider, we see latency in several places, and we are doing mobile service, so the most difficult part is to control the latency in the air or the mobile part, because it's not just one link. There's like, we have like 40 million customers, and they are in diverse places, and we have to control the latency everywhere. So that's really costly, but that impacts the quality of service, so we put enormous effort into that. So that's where it costs most. And compared to that, the link between data centers and changing devices, that's something more straightforward, and we can work with it. And what we need there is we need a technology or a standard that's available so that we can just use it so that we can get a better latency in that part. Another tough thing is if we make a straight line instead of having a non-straight line, straight line gets better latency, but that is really costly to do. And so I hear some operators do it, but it's a tough thing to do. So what I'm trying to say is working on the devices as this ION Global Forum is doing, that's really straightforward answer, and it's something workable, and I think it's the economics works. So it's a good thing to do.
And it might be almost by use case versus industry. So a lot of times when we quantify these Accenture works with kind of the actual use case itself. So for example, in financial services, if it's a transaction where we know the value of the transaction and we can actually figure out if that's being impacted by the SLA or by the service quality, you can kind of calculate what the impact is. If it's a trader desk, or if it's the opposite, which is a fraud situation, and you need to actually quantify the decision that actually comes with a fraud decision, which is a multi-billion-dollar problem, right, with credit card fraud, for example. Then you go to a different industry where you go into like maybe oil and gas or industrial manufacturing, and there's a lot of worker safety solutions that we're putting in place. And there's a lot of these on-prem decisions that need to be made, but that's a life or death situation. So it really kind of, you can look at it from a use case perspective too. Any other questions before we jump back to the panel? Okay. Please also think of more. We're also going to give you a chance at the end, but thank you for asking those questions. So hopping back to kind of where we left off, Kawashima-san, one thing is if you just took the lens of ION APN, what use cases are you most excited about? Because you also mentioned something that was interesting. You started to go into how not all data centers are created equal. Some are, GPU as a service, and you can monetize that differently, and some are driving inferences and business examples. So what do you kind of see and are excited about?
So there are a lot of use cases. In ION Global Forum, we have many members from various industries, and we are developing use cases that can address each industry's immediate needs. For financial service institutes are now trying to find a solution for the shortage of data centers in urban areas. And for companies who would like to develop AI-based, AI-assisted products, for example, automotive companies are now trying to develop AI models for autonomous driving, and also for pharmaceutical industries are now trying to develop medicines with AI-based drug discovery. So one of the important use cases is how we can help such enterprises stay competitive in AI-driven product development world. So how they can add AI computing capability to their product development sites. So this is another use case we are trying to address with ION APN. So as I said, ION APN will help enterprises to connect their product development sites with GPU computing firms over the wide area network. So the enterprises will be able to maintain their data on their local product development sites, but still can use remote GPU on an on-demand basis. So that's another use case. But I'd like to also introduce one important use case that is related to today's topic, new norm of data centers, which is Meet.Me Cloud. So this is about how the service providers create peering connections. Today, service providers have to gather in a limited number of rendezvous points called Meet.Me Room. But this is causing several issues. One is the shortage of power and space in carrier hotel DCs. And another issue is risk concentration. And another issue is the carbon emission from urban areas. So as a solution, we would like to propose Meet.Me Cloud. So Meet.Me Cloud is basically an APN-based WAN, which enables service providers to create peering connections over the wide area network. So service providers can do not have to gather at a limited number of rendezvous points. Instead, they can have their own gateway DCs wherever they like. Azure may have a gateway DC in this place. GCP may have another gateway DC in another place. ION APN will enable service providers to create peering connection over wide area network. I believe this will be the future of peering because we want to allow data centers distributed over wide area network. So this is I think this will help societies keep growing with the ecosystem of service providers.
Yeah, those are super interesting. You mentioned something in there about kind of carbon emissions.
Yes, right.
So I'm wondering, Lee-Vin, when you look at Nokia, what are you guys thinking about when it comes to sustainability, kind of the greener choices of transformation there?
So I always compare the network as a house.
Okay.
And the house has windows, has layers, right? You have the first floor, second floor. A network has the same thing. So now the ground floor is the APN, then you have a packet layer, then you have a service layer. if you want to really look at energy and energy consumption and how you tackle it, you need to take the whole house into account. It doesn't make sense just to look at one. So our approach in ION and in Nokia is actually to look holistically at the whole network, not at one little thing. One little thing will have a plus, but we need to look at everything at the same time. So that's what we do. And what we're telling here really is deterministicity, low latency, agility, basically, you really want to put that in the photonic layer. And I think that's where we should go for the energy consumption point of view, for the delay, and I think that's the message. So we're looking mainly at that. The last thing I want to add to that is that we're working within the ION, with Red Hat, for example, we're looking at, okay, and it was said by Chris earlier on, we need to have the energy consumption. We need to measure it before we know what to do. We need to have a common understanding of energy on where it's used, a common, is it what? And that's not a funny thing, but is it what that is the unit to compare compute, GPU, and network? What per bit? Does that make sense on the compute? So we're trying to study that. So we need to have connectors. We need to be able to look per network layer, how each network layer consumes, and then take that into what we're going to do with this now. And optimizations, what optimizations? Reloading of the data center building. Is it good to have it in Iceland? It's cold there, but it's maybe too far. Do we want to do a better optimizations on offloading and avoiding packet switches? That's one. The other thing I want to say is that, and I keep repeating it, is that we as an industry, not only ION, we really need to look at legacy protocols. It does not make sense that we are still using protocols that are 50, 60 years old, and we still take them for granted because they're there. Every bit needs to have a meaning, and if it's being transmitted, it should have a meaning. If it doesn't have a meaning, it was wasted energy. It's as simple as that. And I think we should look at that as a whole thing, even protocols as well. Three-way handshaking protocol in TCP/IP, if that's across the globe, that's a lot of 3 ways. You need to do a lot of wasted energy. Again, need to look at it as a whole.
Yeah, in the layers, how do you optimize? Then look at it at the aggregate, and then how do you actually measure it, baseline it, then optimize it? That's good.
So I think I'd like to make one comment regarding protocol. So many people say that for AI computing, latency is not so important because we can allow training run on a batch as a batch job. So we don't need a latency sensitive behavior. But one important point is that we need high data throughput, high data transfer throughput. And with today's TCP/IP protocol, basically, if the latency becomes big, the data transfer throughput would degrade. So we need to define a new data transfer protocol that is distance-free. I mean that the data transfer throughput should not degrade over distance. So this kind of optimization is needed to take advantage of ION APN.
Yeah, makes a lot of sense. Good point. When we're going to turn it back to the audience for questions pretty soon, but the million-dollar question, Derek. Now that you've heard everything we've talked through, what do you expect as the new norm for data centers?
So, in kind of reviewing everything we've kind of talked through, I think what kind of stands out for me is just the design principle of sustainability first within the data centers. The second piece is, I think the evolution of the edge from what we knew it as before was a compute edge to probably a device edge. Right? I think that's what we're going to see in the future. And I suppose the third piece, and probably what we haven't touched on, is AI and automation in the network in the data center. AI, agents, and it actually begs the kind of question around latency as well, because if it's AI, it's going to be a lot more tolerant to a little bit of latency, right? So it was, when you asked that question, that was kind of what was in my head, is that we move from a human waiting to a machine waiting, and it's got very different emotions. It may not walk away. So I think they're the kind of three aspects that have kind of rung home to me, but sustainability first is number one.
That's a really good summary. It's a really good summary. Audience questions. Yes. You can also, I can.
Yes.
Okay, there you
Sorry, this is Adnan again from Enritsu. Talking about the protocols, has ION considered protocol like Quick for usage because it's lower latency, it doesn't minimal handshake compared to TCP and other folks? Like
Of course, we are aware of Quick, but right now we are discussing protocol like RDMA over RDMA because we don't want the data transfer be mediated by some medium network layer. Instead, we want to achieve data exchange between between the memory of one computing resource to the memory of another computing resource. So we want to achieve RDMA. So what we are working on is RDMA over APN. So RDMA is a protocol that is designed for high-performance computing inside the data center. So what we are working on is to leverage this RDMA and make it usable for long-distance data transfer. So this is one of our activities in ION Global Forum.
Can I add something? So the protocols have two aspects to it. The first one, I would say, is a horizontal one, and that means what is each bit doing on each layer. Second one is the stacking of the protocols, because we, in our industry, there was wrapping of packets into packets, and it hits another gateway, and we would add more and add more. I think we need to revisit that. So there are two aspects. So, of course, it's a bit complex, but I think we should look into it, and we've made the choice to look at the one on APN, and that's it for now.
Other questions? Okay, so now this one's for everybody. And let's be very honest about this one, right? What challenges, or what is the top challenge you see in implementing ION APN right now in a data center? And maybe Derek, you can kind of start us off and let us know, like, what types of challenges do you see?
I suppose I kind of talked about this earlier in my talk as well, is that technology is moving fast, so fast, and with AI, this whole wave has hit us really hard. And what we're seeing is different requirements in the data center. I think the real challenge is how do we go with the requirements today and forecast out what we're going to need in the next 5 or 10 years, right? I think that is the challenge. And for someone running a data center today, they're kind of looking to the next kind of 24, 48 hours, right? They're not thinking 10 years out. And I think that's the challenge, is just having that kind of consensus to kind of really kind of step back and look at what's going to evolve over time. That's why I kind of really kind of move towards the whole sustainability impact, because the requirement and need for data centers is only growing exponentially, right? But the challenge around sustainability absolutely exists now, and it's something that we've got to look to solve in the very near future. So that's kind of my view on it. It really is, how do we prioritize?
Yeah, excellent. Levin, how about you?
I would echo what Derek is saying, is that the demand will drive what we need to do. And I think the main driver we have is of course capacity and all that, and where we're going to put stuff. But I think the green approach, the green factor on what we're doing is going to be the biggest one, plus the demand, and then that will gate ourselves forward. I mean, we can look forward, but we cannot look too much forward. Yeah. We're trying to get ready.
Yeah, like traditionally, it's always been a requirements and technical demand problem. But now, because of AI impact on the data center, there's the challenge of power, there's the challenge of compute, there's the challenge of real estate. So sustainability, actually, to both of your points, now is like at the top, and that's a very different model than in the past. So that's super interesting. Kawashiro-san, what do you think?
I think I would raise two challenges. One is technical, and the other one is business challenge. So the technical challenge is we need to ensure multi-vendor, multi-operator interoperability of APN. Today's RODAM systems are designed to be operated within one organization. But when we do use cases like Meet.Me Cloud, we have to assume that one transceiver chosen by one organization will talk to another transceiver chosen by another organization. So one transceiver may from Ciena, and one transceiver may be from Nokia.
Sure.
So this kind of multi-vendor, multi-operator interoperability has to be ensured. This is why ION Global Forum is leading Open APN as a community effort. And regarding the business challenge, we need to do more techno-economic analysis, like today's question, how we can translate the latency saving into economic gain. How the data center operators or infrastructure providers can get economic gain by replacing packet switches with optical transponders. So this kind of techno-economic analysis is needed to persuade more providers into adopting ION APN. So this is also this will be another role that ION Global Forum can play, because we have many experts from many industrial segments.
Yeah. I would just add to that, it's also what's the cost of the latency, not just the monetization opportunity of gaining the performance. There's also the flip side of that, which is what's the cost of missing that as well.
Yes, right.
But yeah, excellent points. Maruta-san, what do you think?
Yeah.
Challenges to this.
So your question was about challenges of implementing ION. But I would say the current challenge that we see is there, and I'm expecting ION to solve those challenges. And the challenges is quite similar to what Kawashima-san said. It's interoperability. And if the interoperability is available, then we have more choices and we can reduce the cost. And I see a lot of use cases on that. The reality is it's kind of locked into vendor solutions, and we cannot interconnect other vendors to, so we cannot make a heterogeneous environment. That's the reality of the world we're living in. And if this global forum is going to solve that, and I'm expecting it's going to solve it, and that's going to be a great benefit for us.
Yeah, great point. How about Maninder, what do you think?
Yeah, I think on the cloud side, predominantly it's availability of the capability. Is this capability available at every place where you meet the cloud provider? Because it's a nascent technology. We have, let's say, Google Cloud, we have 202 POPs globally. We won't be able to service all of them. So availability of the technology, and will it be able to connect back into the customer environment at the right place and terminate the right level of thing. Second, I think it was very well mentioned on cost, business benefit. Any new technology, especially a speed transition, comes at an additional cost. The economies of scale take in, brings the cost of the optics down. This is a much more sophisticated technology than we went from 10 gig to 100 gig to 40 gig and then introduced 100 gig after that. This is fundamentally changing how the optical technology is going to evolve. And which also means, will it be economical at lower bandwidths, or will it be economical at higher bandwidths of transfer? So that is yet to be determined. Maybe it starts becoming economical when you're at 800 gig or north of that. But I think the rest the team captured really well.
Yeah, the fact that it's getting to be more sophisticated is a great point that you made, that before it was a very, almost like linear calculation. It's very easy to kind of look at that. But now there's so many different vectors, and sometimes they're almost competing on that, so that's an interesting point. So we're going to wind this down, and I think if there was 3 things you would remember from this, it's number 1, clearly AI has actually put an incredible demand on the data centers, and we're gonna have to fundamentally change that to a new norm. Number two, that impact has pushed cloud, compute, storage, real estate, cooling to its absolute limits, and there has to be some optionality behind that. And then number three, if you look at the innovations that ION has put forth on APN at the technology layer, and you combine it with this group of ecosystem players who are working together to solve some of those big problems, and then you look at the actual business model, I think that's where success lies in the future. So please, a big round of applause for all of our panelists, and thank you so much for coming.